class number 2 of basics and feedback control system. Here we will see, we will define the term sensitivity, and if the time will allow, then we will see the problems also. If time will not permit, then we will see this problem in class number 3. So here we will see in continuation of class number 1, whatever we have explained, we have told a term sensitivity. So I will explain in brief what is sensitivity and how we calculate sensitivity of any term with respect to other terms. Negative feedback for all practical purposes, and positive feedback is used in oscillator. So let me write this thing also. Generally, negative feedback is used for all practical purposes except some, because positive feedback make the system more unstable. Okay, let me write the second point. Generally we use positive feedback in oscillators. Positive feedback in oscillators. So now let me discuss what are the advantages and disadvantages of the feedback system over the non-feedback system. Non-feedback means open loop system. So advantages of feedback system. So the first advantage is the sensitivity of the system reduces. I will explain what is sensitivity of the system. So the first advantage is the sensitivity of the system reduces. The second advantage is the we get control over the system dynamics. Third advantage is the effect of noise is reduced, and fourth advantage is the bandwidth of the system increases. So these are the four advantages, but there is one disadvantage also. The gain of the system decreases by a factor 1 plus GS into HS. Actually we are taking negative feedback system, so 1 plus GS into HS. So the gain of the system decreases by the factor 1 plus GS into HS. Okay. So, but this advantage can be compensated by making the open loop gain, by making the suitable open loop gain. The advantages overrides, or you can say the advantages are, there are more advantages than disadvantages. So we use closed loop system instead of open loop system. Okay. So what are the advantages? The first advantage is sensitivity of the system reduces. sensitivity of the system reduces. I will define later on, and I will explain what is sensitivity. Second advantage is we get control over system dynamics. Third advantage is effect of disturbance, or you can say noise, reduces. The effect of disturbance, or you can say noise, reduces. And the fourth advantage is the bandwidth of the system increases. The bandwidth of the system increases. Okay. And disadvantage, what is the disadvantage? Disadvantage of feedback system. The gain of the system reduces by a factor 1 by 1 plus GS into HS. The gain of the system reduces by a factor 1 by 1 plus GS multiplied by HS. Here I have taken the negative feedback case. So this is the disadvantage, that the gain reduces by the factor 1 by 1 plus GS into HS. But this could be compensated by making the open loop gain K the desired open loop gain K. But let me write here, but this can be compensated by making suitable open loop gain K, or by choosing suitable open loop gain factor. So we can clearly see that the advantages overrides the disadvantage. So the advantages override the disadvantage. So open closed loop system is more advantageous, or you can say feedback system has more advantages than the open loop system. But and the second disadvantage, this is the first disadvantage, and the second disadvantage also, the closed loop system is complicated and expensive. So let me write other disadvantage this side here. So let me write other disadvantage here. The closed loop system is more expensive and complicated. The closed loop system is more expensive and complicated. Okay, so these are the advantages and disadvantages of open loop closed loop system as compared with the open loop system. But finally, the advantages override the disadvantages. Okay, now let me define what is sensitivity. I have used a term sensitivity. Let me define what is sensitivity, what is dynamics. So all of you know what is noise. There is no need to explain disturbance or noise. Noise is some unwanted signal which are getting mixed with the original signal. Any unwanted signal which is getting mixed with original signal is called noise. Suppose I am teaching you, and some, you can say, some deck is someone is going and someone is blowing horn. So horn is noise for me, but for that person who is blowing horn, that is not noise, that is a signal, that is the required signal. My voice is noise for him. So any unwanted signal is called noise. Noise may be a noise. So there is no exact definition of noise. We can say the blowing of horn is noise. So blowing of horn is noise for me because I am teaching and the students are getting disturbed. But blowing of horn is not noise for that driver, that vehicle driver, because that is the signal which he is using for his safety, for other safety. Okay. So noise is also with respect to what we are talking. So I think you have understood what is noise, what is dynamics. So I have used, we get control over system dynamics. Actually, when the system starts, then it doesn't reach on the steady state. It takes time. Like if you start your bike, then and you want to drive it at 60 km/h, then eventually it will not reach at 60, and you can say spontaneously it will not reach from 0 to 60. Between 0 to 60, to reach from 0 km/h to 60 km/h, it will take some time, and that time is called the dynamics of the system. So you can say transients also. Transients of the system are called dynamics. So we get control over system dynamics. Now system dynamics reduces, actually system, by use of this feedback, the system dynamics or you can say the transient period of the system reduces. So let me write here in bracket reduces. So by use of feedback, the system dynamics reduces. So now you have understood what is system dynamics and what is sensitivity. So let me define the term sensitivity. What is called sensitivity? So let me wipe out these things. So another term is sensitivity. And what is sensitivity? The sensitivity of, suppose we are calculating the sensitivity of a transfer function whether it be a closed loop or whether it be a open loop. So let me write the negative feedback, the transfer function for negative feedback system. So the transfer function for negative feedback system is transfer function of negative feedback system is Ts equal to Gs divided by 1 plus Gs into Hs. Now the sensitivity of this transfer function Ts is defined as, if suppose we are changing Gs, okay, so the rate of change of transfer function Ts with the rate of change of this Gs is called sensitivity of Ts, transfer function Ts with respect to Gs. Okay, you have got. Similarly, if we are changing Hs, then obviously Ts will change. So the rate of change of Ts with respect to rate of change of Hs is called the sensitivity of transfer function Ts with respect to Hs. So now you have understood what is sensitivity, and so let me define sensitivity first. So it is defined as sensitivity of any term with respect to other term, any term, suppose A. So sensitivity of any term suppose A with respect to the other term B is defined as the rate of change of A with respect to rate of change of B. Or in other words, we can also say that it is the ratio of rate of change of A is to rate of change of B. Or we can say it is the ratio of rate of change of A is to rate of change of B, and it is denoted by SAB. So what will be SAB? The expression for SAB, the expression for SAB, this will be nothing but del A by A divided by del B by B. So what will be it? It will be del A by del B multiplied by B by A. So this will be the sensitivity in absolute term. In percentage term, percentage sensitivity equal to del A by del B multiplied by B by A multiplied by 100. This much percent. So now it is clear to all of you what is sensitivity. Now we will determine the sensitivity of closed loop transfer function with respect to G and H. So let me write out these things. Now what will be STG? So what is STG? STG means sensitivity of transfer function T with respect to G. So it will be del T by del G multiplied by G by T. Okay, as we have got just now. So if we partially differentiate T with respect to G, then it will come 1 plus G S H S whole square. Here 1 plus GS multiplied by HS, okay, into 1, because if we differentiate GS by GS, then it will be 1, minus GS multiplied by the differentiation of this. So the differentiation of this will be with respect to HS with respect to GS will be HS, okay, multiplied by what is G? G is again G, and what is T? Let me write G by T itself. I will write later on. So this GS into HS get cancelled by this GS into HS. So now we are having 1 plus GS into HS, this whole square, okay, multiplied by G divided by what is T? T is again GS by 1 plus GS into HS, okay. Now this G cancel out, and now we are left with, and this will also cancel out, this G cancel out this, and this will go in numerator and cancel out 1 power, and finally we will get 1 by 1 plus GS into HS. So sensitivity of T with respect to G is equal to 1 by 1 plus GS into HS. But before that, in open loop system, what was the transfer function? It was the transfer function was GS itself, and the sensitivity of that transfer function with respect to G will be 1, and now we are getting the sensitivity is 1 divided by 1 plus GS into HS. So clearly we can see that the sensitivity got reduced by the this factor 1 by 1 plus GS into HS, because for open loop system the sensitivity was 1. Now let me calculate the sensitivity with respect to H. So sensitivity of T with respect to H, okay. So it will be del T by del H multiplied by H by T. So it will be nothing but since 1 plus GS into HS whole square multiplied by 1 plus GS into HS, okay. If we differentiate this with respect to H, then it will be 0, minus the differentiation of this. What will be the differentiation of this? So the differentiation of this will be with respect to H. Now we are differentiating with respect to H, so it will be GS multiplied by H by T, okay. So if we do this, then we get G, this is G divided by, so GS divided by 1 plus GS into HS whole square multiplied by H divided by what is T? T is nothing but GS divided by 1 plus gs into hs. Okay, so this 1 plus gs into hs will go in numerator and it will cut one power, and this g will cut this. Okay, so now how much we get? Now we have worked, and here one more thing will be there. Since it is gs, here what we have done here, let me see, here it is gs, and since it will be gs is here, so gs multiplied by again gs. So let me write here, gs multiplied by again gs. 2 gs will come, because one gs will be in numerator and another, if we differentiate this term, then again gs will come, multiplied by h by t. Okay, now it is okay. So it will be gs square, not only gs, it will be gs square. So this will be gs, this will be gs, but it will be gs square. Okay, gs square. So one power will cancel out here. So finally we will get minus gh divided by 1 plus gs. Okay, so this will be used as formula for future purpose, and this will also be used as formula. So you have to remember these two terms, the sensitivity of transfer function t with respect to g, which is coming 1 by 1 plus gh, and sensitivity of transfer function t with respect to h, which is coming minus gh by 1 plus gh. So now let me wipe out. Now I think you have understood all the terms. Now I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video. If you subscribe my video, then there will be no need to search the new videos. Automatic update will come to you when I upload the new videos. What you have to do, it is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.